Today's video is going to be about a little bit of a theory about using line trace for wheel collisions. Instead of physic collisions. Okay, so let me just draw a line in here. Let's say whatever color that is, and that's not a line at all. Okay, let's say this is the ground, okay? And let's say this right here is my vehicle, right? So the default vehicle class uses line traces, which I'll put this color, to detect the ground, right? Here, we just found where the ground is at. Which means that, of course, if you add a bump, it won't collide with the bump, right? The vehicle is just hovering above it. You know? So it's gonna detect only the flat surface here and here, right? Now, what I think I could do, is use a sphere trace to simulate wheel collisions without actual collisions. So let me explain what I mean by that. For example, here you do a line trace, well, a sphere trace instead of a line trace. So it's gonna trace a sphere, all right? And it's gonna return collisions here and here, right? And with these two, you can find the direction, which I'll put another color, the direction at which you need to add force. Something like that, right? So you get a working suspension, and the vehicle is going to have some horizontal force applied backward so that it doesn't just glide over the bump. The bump actually slows it down, right? And then because it's a sphere trace, you get collision response all the way around that circle. And so you don't get that, only detecting top and bottom of the bump. You actually trigger detection all the way around that sphere, right? And so using that, I could, just like I do now, simulate wheel collisions. And so, yeah, I'm thinking about doing something with this to get wheel collisions with line traces, so I don't have to use the physics constraints, which are excessively buggy and have a pretty hard impact on the frame rate. And I would pretty much gain the exact same results, but more stable, less buggy. Using mathematic instead of the physics engine would also be more predictable. It would give more consistent results. And so, yeah, I'm thinking of using that. And I kind of wanted to know your opinion on that. And of course, seen from above, let's say here's the top of our sphere. Here is the forward vector starting from the center of the wheel. Then I could get the angle of where I get the hit, right? So let's say I'm getting hits all over there. Then I can detect their angles from the forward vector and say, for example, if angle is more then 20%, then I'm only taking the hit into account if it's a certain distance from the center, which means I would effectively ignore collisions from the rest of the sphere, which would, you know, create kind of cylinder shaped detection with the line traces. And then that would allow me to have cylinder collisions, which would be great because then I could apply force to the sides of the tire if there's an obstacle on the side of the tire, and it wouldn't react like a sphere anymore. But that right there is a lot of mathematics, and no more physic engine anymore, you know, just line traces and math. So yeah, that would basically be a lot better solution for the wheel detections, if I can pull it off, which I'm really unsure about. So yeah, this would actually have a lot of advantages, some of which are better performance. And then since I handled the friction of the tire via mathematics instead of using the physic friction, then I can separate the lateral friction from the forward friction and get a little more control about how the tire is actually drifting. Because, you know, there's no actual collisions happening, meaning no physic acids, no physical material. So yeah. So this would, in many ways, looks a lot more like the default vehicles, except with sphere traces that I then turn into a cylinder. So yeah, I don't just glide over the bumps. The bumps actually slow down the vehicle and stuff like that, just like it does now with the physic vehicle. So yeah, that's the theory behind that little test I'm gonna do tonight and for a few days probably. So I'm gonna mess around with sphere traces and see if I can get that to actually give me a cylinder collision detection that I can use instead of the physic engine. Because yeah, I've kind of reached the limit of what the physic can do in the Unreal Engine. At high speed, the wheels get stuck on collisions and it just glitches everywhere. It's ridiculous. So yeah, I kind of have to change the method I use. I think that would be it. But of course that implies to redo the whole thing pretty much from scratch. Except, you know, the camera stuff and the possessing passengers and all that. But, you know, the main way that the wheels work would have to be redone from scratch. And then, you know, just like the default vehicle, you would use the animation blueprint to place the wheels at the hit location plus the radius of the wheel so that they look correctly positioned, right? So yeah, that's pretty much what I wanted to mention in this video. I hope you could actually understand what I was trying to say there. But yeah, just let me know in the comments if you want me to live stream those attempts I'll be doing. I'm not too sure exactly how to do a line trace vehicle, since there's no tutorials on that at all, since there's already one existing, but I can't use it because it's all made in C++, so I can't really modify it. Unless, well, I actually could keep the line trace from the standard vehicle and just add a sphere trace onto it instead of redoing my own class. I guess I could do that. So yeah, I'll be messing around with that today. Well, tonight, tomorrow, or a few days in a row. See if I can actually get a decent result. And yeah, I'll keep you updated. So that's it. If I succeed, which is absolutely unsure, but if I succeed, you'd get basically a proper whale simulation. That's actually a cylinder instead of a sphere. And yeah, more stability, less frame rate hit, which mean more suited for multiplayer and a lot of vehicles in the same map. Because the physic engine is pretty hard on the frame rate compared to a bunch of line traces, or sphere traces in that case. So yeah, that's it. I'll be doing that. And that's it. Yeah, just let me know in the comments what you think of that idea. If you have any suggestions, any questions, if you want to see me live stream that. It's going to be pretty boring to watch, you know. I'm just going to spend countless hours doing trials and errors, testings and stuff. So I'm not actually sure anyone wants to see that, but yeah, if you tell me you do, then I'll live stream it, I guess. So alright, I'm gonna cut the video there. Just let me know what you think in the comments. I'll see you.